Hello, my name is Pavel Krupola from BlenderFreak.com, and today in this part of the Node Editor tutorial series we are going to have a look on the edges. So we will start creating a representation of the edge. We will create two types of edges. The first one will be direct, connecting point A to point B, and the second one will be the Bezier connecting. These will be selectable, as you can see, and we will distinguish it with a different color. So I hope you are excited, and let's get started. Okay, so here is where we left off. We got some awesome node and it has sockets, so let's start creating edges. For that, first off, I should probably create some other nodes. So we can go up here to the node editor window, and we can create three of them, like node 1, node 2 and node 3, node 1, node 2 and node 3. And as you can see, when I started, there are 3 nodes, but each of them is on the same place, so it would be quite handy to be able to say something like node 1 dot set position and say, for example, minus 350 comma minus 250, like this, but we don't know the set position because we didn't implement it yet. So we can go ahead to the node class and we can say define function set position, like this, and say x and y, and then because we are using gr node, we can say self gr node, and there is already a function called set position, and we can pass x and y values inside. So probably it would be nice to have some kind of maybe property. Define position self, and this one will return self gr node dot position, and this will return q point f class, I believe. So therefore you will need to call it like position dot x and parentheses and stuff like that, but you probably already know that. So we got a position, we got our set position. Let's try that out. Yes, and the node is moved up. So I will quickly set up the two other ones, and we can say the node 2 will be something like minus 75 comma 0, and the last one will be 200, and y position could be minus 150, let's say. Okay, this looks cool, so let's go ahead and create some edges. So let's go ahead and start creating edges. For that we will need a new file, and we will call it node edge, and let's start what we know definitely will be needed for our edge. So class edge will definitely have a constructor, and inside the constructor we will pass the scene, so we can add the graphical representation of the edge to the scene directly when we are constructing the edge. And once we are constructing the edge, we will probably have the edge connecting the sockets. So we will pass start socket and we will pass the end socket, like this. So let's store the variables. Self scene equals to scene, self start socket equals to start socket, self end socket equals to end socket. So after we got this, we can create the graphical edge. So let's say self gr edge will be our own class, and we will call it, for example, qdm graphics edge, like this, probably. And we will pass directly the reference to the edge which we are in, like this. We can now probably call the scene graphical scene, and we can add item which will be self.grh, like this. Okay, nice. We don't know the QDM graphics edge, and we will import that from file which will be called node graphics edge. Import QDM graphics edge, like this. Okay, so let's save that. Let's create a new file. Node graphics edge. Create a class, and this time we will derive from one awesome PyQt or Qt5 class which already exists, and this is called QGraphics, and it's not gonna be item, it's gonna be path item. So from PyQt5 Qt widgets, import everything and define the constructor again, and we are going to pass an edge and the parent, which by default will be again none, like this. And then we call constructor of the base class, and we will pass parent like this. So let's store the reference to the edge like this. Okay, and the reason why we are using QGraphics path item is because this class got really nice awesome features, like you can set the Z value as usual for the graphics item, you can set brush, selectable, movable, calculate bounding boxes, bounding rectangle, colliding items, which could be really handy and will be in the future. We can have hover events, input method hints, is visible, is widget, blah 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 blah, a lot of stuff, but most important is this one, PATH, path. So path is a QGraphics path item, which is not really helpful, but there is a set path variable or method, like here, where we can pass QPainter path, and QPainter path is basically the easiest way how to paint direct lines, arches, curves, Bezier curves, etc. So we will use this setPath function to create our own types of edges. So let's say the first one will be something like a Bezier edge, and the second one could be, for example, like direct edge, and we will just override the necessary methods so we don't repeat our code for creating these two types of edges. So first off, everything is going to be paint in the paint function, which we will override right now. So first off, I will rename this parameter to painter, and once we got painter, we can, as usual, we can set pen, and we will say that self._pen will be used. We can say painter.setBrush. We won't use any brush, so Qt no brush. Again, we do not know what is Qt, so from Qt core import everything. Should be working now, and then we can say painter.draw path, and we can say self path, like this. Nice and easy, isn't it? So What is actually the path? We don't know yet. We need to calculate what the path actually is. So we will create a new method which will be called update path, and this method let me write it in the comment, will handle drawing cube painter path from point A to B like this. But I do actually want to have different classes representing the different types of edges, because I don't want to have like 6 types or 7 types and having one long if type equals to 1, then do something, and on the next lines type something like elif type equals to 2, blah blah blah, etc. I don't like that. So we will keep this class abstract. That means itself this class won't work. Once it's instantiated, it won't work actually, and we will make sure for it's not working by raising an exception. So we will type raise not implemented. This method has to be overridden in a child class like this. So anytime you instantiate this class, once it goes to the paint method, it will call update method, update path, and the update path will crash your application with an exception in case you don't catch it. So you usually won't. So that means we will have a new class, and the class can have name QDM graphics edge, let's say direct, and it will derive from QDM graphics edge, and there will be just one method, and it's gonna be update path, and here I will calculate the QPainter path for connecting from point A to point B. The next thing we can have is class QDM graphics edge Bezier, and this will be again QDM graphic edge as a parent, and define update path, and again I will pass here a path. So go to the node edge, and here I can't have QDM graphics edge for now, and I will use direct like this, and that means I need to put a star here or type the name of the two classes I need. Okay, so what can we do now? We can test if the path is actually drawing something. So let's, you know what, let's go first to the node editor window. Let's clean this a little bit. So I will move it to add nodes method. We don't need this. Define add nodes and paste it here, and here I can go say edge1 equals to edge. It will be in the scene, and it will connect socket, which one? Node 1 outputs, the first output of node 1, and this will be connecting to node 2 inputs and to the first input. We don't know the edge yet, so let's go ahead and actually import that. We are not using a socket anymore, so probably we can go ahead and type from node edge import edge like this, and this way we got created an edge, hopefully. But it crashed, and it crashed because why? This should be okay, because update path does nothing, and we don't have pen set up, and we do not know what the path actually even is. So let's go ahead and start creating few things. So self._pen equals qpen, q self color, like this. We don't know pen, so from pyqt5.qt GUI import everything. So let's define the color, and we will say for now color will be q color, and we will use I don't know 00, 10, 00, and we can, what we can do next, we got no pen, no brush, pen is okay, it's no now, and the path. Okay, so let's implement the direct connection from socket A to socket B, but I don't wanna implement the get socket positions XY and stuff right away, so I will say path is new q painter path, and it will start in point, which will be self position start source, and x position, and self position source, and y position. So what's position source? Position source self position source will be by default a list of two variables x and y. This will be where the edge will start, and position destination will be for now 200, 100. So we will start our painter path here in position source. Then we will go ahead and say path line 2, and we will set the destination. So this will be self position destination 0, comma self position destination 1, and then we can say self set path, and we can say qpaint path, which will be our path. So now when I press play, you can see we got nice awesome line representing our edge from 00 to 200, 100. But I don't see it very well, so let's go ahead and adjust the pen, self._pen.setBit, and let's say 2.0. Now that's better. Okay, I can see that. And what we can do, we can say self set flag, and we can say that q graphics item dot item is selectable, like this. And now we can try select it, and we don't see anything. The reason why, because it's being drawn just with one single pen. So let's go ahead and create color underscore selected, which will be, let's say, green. The same way we will create pen selected from color selected, and set the width to be the same, like this. So this is our pen for the selected part, and here we can say that we are going to use self pen only if self is selected. not. So if this actual item is not selected, we will use the default pen, otherwise we will use self_pen selected. Like this. When I press play, you can see if I manage to click on it, the edge goes green, which is awesome. We will use this feature later. And what we can do now, we can start working with Direct Edge and Bezier Edge. And in our case, we could specify in the constructor the type of the edge, which will be by default 1. And what will be 1? This will be a constant, so we can call it edge type direct equals 1, edge type underscore Bezier will be 2. So by default the type will be direct. So let's say that self gr edge will be qdm graphics edge direct only if the type will be equal to edge type direct. Otherwise, this will be qdm graphics edge Bezier and pass the reference to the edge. Now when I press play, nothing is broken, which is awesome. So we can go to the node editor window here and we can create a second edge, which will go from node 2 output to node 3 input 1, and we can say that the type will be 2, which should be the Bezier edge, but nothing is being shown. Nothing is being shown because we didn't implement any update path method for our edge Bezier. So we are going to start from path. It will be again q painter path, starting from q point f, self position source x, self position source y, like this, and at the end we will call self set path to the path, like this. This should be already working and crashing. It is awesome. And here in the path there are a lot of things like add polygon around the rectangle or a method called cubic2. This method, which I don't understand too much, is working like this. It's a cubic Bezier curve between the current position and the end position. So here is the endpoint x, endpoint y. These are the last two parameters, and with control points specified by c1x, c1y, and c2x, c2y. So let's say we are going to pass the destination, because we know that the destination will for sure be position destination 0 for the x and self position destination y, like this. And here we need 2 points, control point 1 and control point 2. So I already filled around and I come up with this solution. So we can say that S for our source will be just a holder, so I don't need to type this all the time again and again. Position source, and destination D will be self position destination, like this. Then I can count the distance between these 2 points, which will be distance destination x minus source x, and then I will divide it by 2, so I can type multiply 0.5, and in case that the destination is on the right side, everything's okay. But if it's the other way around, I need this destination to be in minus, so I can check if source X position is bigger than destination position, and then I can take distance and multiply it by -1, so I can revert the distance, and with this variable I'm able to use it like this. Source X plus distance will be the first control point, and it will have the same Y location, and the second control point will be destination X position minus distance. So let me put a blank space here, and the Y will be still the same. Okay, so this should be working for creating a cubic path. So let's test it out, and as you can see, we got nice Bezier curve going from one edge to one corner to another corner, and these are still selectable, hopefully. Maybe not. Ah, yes, I need to be precise and not having this over the other one. Okay, so we'll fix that later. And as you can see, this is one minor thing which is bothering me, and the edges are over the sockets, and I need them to be, or I want them to be underneath the socket. So I can go ahead, let's say here, and I can say cell set z value and put -1, and now as you can see, the edges are under the sockets and they work and they are looking awesome. Okay, so this is everything for this part, and next time we are going to look at how to start positioning these edges and use them a little bit more and better. So thanks for watching, and see you next time.